Let's go.
Hello, everyone. Hope this new year is treating you well. Welcome to our hackathon project, Audible Tweet Fund. This tool is being developed by 3 team members, Spencer, Nidhi, and Gilbert. What does this Audible Tweet do? It asks the user for the Twitter username or for their favorite Twitter users. It gathers the most recent tweets from their Twitter screen, and finally it calls the registered phone number and speaks out those tweets in their default voice. Now, what does this tool will help out to? I think multitasking is part of our lives now, especially with the work from home framework. For many, we are juggling between jobs and we want to really hear out things rather than to stare at the screen, right? It at least helps me out to like listen to music or say talk with Alexa or Google Home at this point. So this tool is helping out in the similar way, wherein the user can just play out or hear out their tweets from their favorite users, from their favorite Twitter artists actually. This tool can also be expanded to help out the visually impaired people to enable them to hear our tweets. Our app is using Python language. We are also using Tweepy library to leverage the Twitter API to get all the Twitter contents. And finally, we are using Twilio API, which in turn allows us to play the cumulative tweets that we got from the Twitter API into our cell hash. And now it's time for some fun, and my team members, Spencer and Gilbert, will show how the app actually works.
Thank you, Nidhi. So now I will go over to our code and execute our application. So as you can see, our program prompts the user for a Twitter handle, in other words, the Twitter username. We decided, since we're UPenn students, we will extract tweets from one of the most famous UPenn alums, Elon Musk. So I will enter Elon Musk's Twitter username, and then it prompts me for a 10-digit phone number, which I will enter. As you can see, the program prints out Elon Musk's 5 most recent tweets. For example, the most recent tweet, Elon Musk talks about his 14-year-old son, Saxon, feeling like 2021 will be a good year. So before I execute the final step of this program, I will stop sharing my screen and pass on the screen sharing to Gilbert, who will share his phone screen so that we can see the program in action.
Thank you, Spencer. Just give me a little time to screen share my phone. And you guys should be able to see my phone now.
Great, so now I'm going to execute the program and execute the call.
This message at any time by upgrading to a full account. Press any key to execute your code.
Tweet number 1. My 14-year-old son, Saxon, said he feels like 2021 will be a good year. I agree. Let us all make it so. Tweet number 2, launch underway. Tweet number 3, BTW. Critical feedback is always super appreciated, as well as ways to donate money that really make a difference, way harder than it seems. Tweet number 4, there is an image. Tweet number 5, use.
Awesome. As you guys just watched the demo, you see that this Audible Tweet app is really powerful and really fun to use, right? And as we're making this app, here are some of the key learnings and takeaway the team learned during the process. So first, we're able to learn new knowledge, like, for example, using the Twitter API, the Tweepy library, the Twilio API to extract tweets, as well as customize the default message to be played during the phone call. We also learned how to authenticate the API using various secret tokens. Last but not least, part of the process, we learned how to collaborate and communicate as a team to build a great product within a short period of time. Towards the end of our project, we thought about different ways to improve this app in the future. So here are some of the ideas that we have in mind. For example, deploying an app or website that the users can visit and initiate the calls for user-friendly purposes. Second is to add functionality for user to register their own cell number. Because right now for this project, we are only able to register the 3 phone numbers amongst the 3 teammates, but we're hoping to expand this feature in the future. Next is to create a virtual environment to encrypt our API credential for security purposes. Last but not least, to add functionality to schedule daily tweets updates. We thank you so much for listening, and we hope you enjoyed our presentation. Thank you.
Hi, everyone, and welcome to the MCIT Online Study Smackdown game, which is the study game of choice for Penn MCIT Online students. So Cam and I basically made an online quiz app that allows you to test your knowledge against other fellow classmates. The project was built using HTML, CSS, and just vanilla JavaScript. And I'm just going to hand it over to Cam, who's going to go through a short demo of the game.
All right, thanks, Varanchi. So here is the landing page for our app. When you navigate into the app, there are instructions over on the left. They specify that the game ends when you get 5 points, but for demonstration purposes, we've changed it so that you only need to get 2. It asks you to enter your names and then to pick your courses. If you don't pick courses, however, and try to begin the game, it will alert you that you need to select a course. So for demonstration purposes, we'll select all the courses, which means that a random question will come up from each course every time. So as you can see, this is the game screen. In the game screen, the question is displayed at the top. There's a tag saying which course the question comes from. And then there's a submit answer button and 4 answer choices. Over on the right is the scoreboard, which has our names in it and then dynamically updates the score. And it also says at the bottom whose turn it is, as well as highlighting the person whose turn it is. So I will go first. I just started 594, so I'm going to give this my best shot. I think it's this one. Hey, got it right. So then the submit question button turns into the next question button and go to the next player. So Varanchi, what would you like to select?
Right, I will select C.
C. Excellent choice. Okay, I do know this answer, I promise, but I'm going to select this one for demonstration purposes. You can see since I got it wrong, it is highlighted in red and the correct answer is highlighted in green. And now we'll go back over to Varanchi, and since 2 is the maximum score right now, if he gets this one right, he will win.
All right. What is the recurrence relationship worst case for quicksort, and what is the time complexity in the worst case? I'm going to go for D.
D. You were incorrect. Okay. This one is the cloud. So now the game will end. Ta-da. So now we go to the end game page. It prints out who the winner is with a nice little banner. And then this changes colors to sort of draw the eye there and gives a little congratulatory message and asks if the player would like to play again. On the left-hand side, we have a little MCIT Online advertisement panel, which basically just has information about MCIT Online. There's a video that people can play, and then they can also navigate to the admissions page if they'd like. Then over on the right is a little about for each of us. And if you click on our pictures, it routes to our LinkedIn pages. So now turning to some challenges we faced while designing the app. This is one of our biggest challenges, which was developing an app that rendered well on both desktop and mobile environments. That required us using CSS Flexbox as well as viewport density and media queries to allow CSS to look at the screen size that the page was being rendered on, and then it would either render in the full desktop version or in this more mobile-friendly version. So as you can see, it still works exactly the same. And the gameplay page is all displayed on one viewport. That way the user doesn't have to scroll up and down as they use it. So now I'll turn it over to Varanchi to talk about some additions we'd like to make to the app.
Thanks, Cam. We'd like to make the question bank open source and sort of store all of those questions in a database that any MCIT student can add questions to. We'd also like to include or introduce a self-study mode, which would allow the user to basically run through the game with unlimited questions without being capped with a max score. And we'd also like to introduce quiz questions for some of the electives as well. But yeah, in the meantime, we hope you enjoyed this short demo and happy studying.
Yeah, thanks guys.
Hello, welcome to Find Your Next Dream Home. My name is Derek. I'm happy to give you a tour of our website. We want to develop an app that helps the homeowner or prospective homeowners to find their next dream home. So here you can see this is our front page, and you can just press on this right arrow, get into the website, and this is being developed using the JavaScript, HTML, and CSS. So here you can see the Google map here, and the Google map here, we only show the basic function here. We can toggle down, up, left, right. You can see it works, and we can zoom in and we can zoom out. So this is a very nice feature they have, and we really like it. So to your left, you can see the search function, and we list your preferences. So it depends on whether you want to narrow into the price, distance, or usability, anything you want. So you can find a way to just toggle this, then you should be able to see. The price can be coming from 1 to 100, or you can just down here. Just for illustration purposes, you want to set something that you can play around. And we want to find the state. So here we have already put in the state and also the city. So for example, we want to go to Pennsylvania, we're going to go to Philly. And here we can just enter into anything that we want. So for example, we want to find University of Pennsylvania. So this is our home, and this is the location we want to look for. So here, boom, we actually have the 10 locations to pop up right away. Right now, the reason we're only doing 10 is because the API has a cap. So that's the reason why we want to limit it at 10 for now, but this can easily support up to 100 or even more. So right now, if you score in, scoring, I mean, zoom in, and you should be able to see that there's actually score attached to it. So right now we see this is 9.6, this being 8, and this is being 9.2, for etc. So what are these score coming from was actually based on your preferences here. So we have the price, distance, and usability. So what if we change to something else? The answer is yes, definitely we can do that. So before that, I just want to show you that we can also search for another location. Let's do California. And let's pick anything. Let's say we want to do Berkeley. Okay, that's great. Berkeley, of course, Pennsylvania, University of Pennsylvania is definitely not in Berkeley. So let's do the search right now. So you should be able to see, boom, this is an MR10 properties. And right now you can see the score attached to it. And we didn't save the data sets. Actually, API goes there and pull information from us. This is very similar to what we had learned in 595. This is called the HTTP client server that will just send information, they bring us information, and our backend is able to bring back to the front end. So which you can see, this is a nice display here. So I just want to do that very, very quickly that to show you how this thing works. So right now you can see this, this is our program, and this is where the magic begins. So here, down here, you should be able to see this is what would have been pulled last time, and you can see the price score, distance score, usability score, and overall score. So here you can see the overall score is actually listing in a descending order. What does that mean? This means that we want the highest to be on the top. So I think this is reasonable because we always want to have the best house, the best attached to our needs. And the same thing here, we also see this. This is what we put on the Berkeley, right? So you can see right now, this is actually a different property number, and we have the price score, distance score. And very quickly, I just want to do a quick demonstration. What if we change the price, distance, usability? Absolutely, we can do that. And then let's do a search. So right now, if you just check our code again, and you should be able to see right now, this is what we just pulled. So right now, if you see this, this is our original property. Original property was number 1 because the distance was such critical. It was 10 before. So that's our focus. So that's the reason why it was ranked number 1, but right now it's being ranked number 2 because right now we focus on what? We focus on price and usability. So that's the reason why that the scoring is actually swapping the order. And right now, if you see the code, we actually have done something that we actually incorporated the Flask using the Python Flask, building the server, and we in the back end we're trying to use the sorting algorithm and to put them. We also made some decision as we learned in 594 and 596. We know that data structure really matters, so we use a constructor to build them, and we're trying to use as efficient as possible. And we also decide to use, for example, we decided not to use the hash map or tree map. Otherwise, there would be very convenient way to sort, right? Just based on the overall score. But we don't want to do that because imagine if we have 100 properties, 1,000 properties, that's going to be a very difficult task because every time you do that, it means that you're creating a new object. So that's why we don't want to do that. Instead, what we did is really to put this algo to be the most efficient format that we want to use something called argsort. But we don't want to use NumPy because not everyone has NumPy installed. So we just kind of want to put this all together and make sure all the users can use this. And I just want to show you the code very quickly. So this is really our sorting algorithm that you can see this is a very convenient 2 lines to help us to sort that. And such decisions are being made when we are doing this. There were a lot of objectives that we haven't been able to accomplish, such as the address and the polling and the photos, the tours. But I think this is sufficient, and we really hope you like this project and find this useful. And thank you very much for watching, and I will see you on the live demonstration. Thank you very much. Have a good day.
Awesome. Let me show you the game that I built using purely Java. So it's a snake game where we have 3 classes. The first is the snake game frame, and then it's the game panel where actually how the play is going on, and then the third one is the main method of the snake game. Let's run as Java application. We can see there's the red dot is the food, and then the white indicating the snake's head. We can use the keyboard, the 4 arrow key, to control the movement of the snake. And then we eat. We can see there's a score on top of the screen that indicating how many food that you've been eating. So if we don't want to play, we can either hit the walls or hit its body, and then that's going to be the game over. There we go. Yeah, that's basically what I created.
Hello. For this hackathon, we developed the MCIT to-do list. The members of the team are Claudia Fernandez, Kevin Liu, and Francisco Urra. MCIT online students have several courses, and each one of them has assignments, homeworks, exams, and projects. We implement the MCIT to-do list. That is a web application that shall help MCIT online students track their tasks per course. We used MongoDB and Node.js to create this application, and next we will show you a demo.
Okay, so here we are at the homepage of our to-do list app. As you can see, it's a very uncluttered layout. And right away at the homepage, you get a nice little introduction of what the app does. And then you have your email address and password field so that you can log in. And of course, if you don't have an account yet, you can sign up for one. Additionally, we also have a nice navigation bar so we can navigate around the website. If you try to go to a course try to go to a page where you can make a list, you'll see that you're unable to do so. The authenticator will realize and will kick you back out to the home page so you can log in. So let's first see what happens when you log into an account. So here's our dummy user. So you see dummy user's already got some tasks going on. We can add some more. see, yeah, we can add tasks. And then if we complete tasks, we can click the check mark, and then these tasks will move into the completed section. Additionally, besides general, we can also make tasks for our classes, which is the purpose of this to-do list. So you can add tasks again for these. And again, you can click on them to complete the tasks. So that's for one user. For any user, you can do this. So now, suppose we want to register a new user. You can do so. Sign up. Let's do another, I don't know, person. Yeah, I'm not very creative with the names. So we're making a new user, register, and then this user, since they're new, everything will be, all their lists are clean. There's nothing here. But again, you can easily add some tasks. So yeah, so that's the basic functionality of this program. And in the future, the hope is that in addition to seeing the tasks that you complete, for users who opt in, we can have a stream of popular tasks that the community engages in. So for example, if you were in, say, 596 and then you're not sure what you want to do, and then maybe in the stream you see a lot of your classmates are, I don't know, studying onto some online resource. If you see a lot, you might see a lot of people doing that, and then you can, you have another resource that might be able to help you in the class. So again, yeah. So then, and again, the information is safe for users. So when you log back in, oops, made a mistake there. When you log back in, you're back. You can see your task list, and it's as if you never left. And cool, yeah, that's the basic general demo of the app. Thanks.
All right, hello everyone. So today we're going to be presenting our project, which is a COVID-19 risk factor predictor. So it basically just shows how relatively at risk you may be from currently identified risk factors. In the end, you'll get a scale of 1 to 10 through our data analysis from a recently surveyed data set from the CDC. Now, essentially what this combines is a lot of different tools and frameworks, such as Flask with Python for web development, and then as well as traditional languages such as HTML, CSS, and JavaScript. So if you run this, you have this menu screen pop up, and then if we click here, we can start our user input.
Yes, here we come to the user input page. And before we started our predictor analysis, and we did some research using the CDC's COVID-19 data set, and then we identified 3 major factors. And these parameters are gender, and then age group, and race. And we got these parameters from users' input, and how we can transfer the user input from the front end to the back end for data analysis becomes a major challenge for us. So we did lots of research and finally achieved it. And next, I'll pass to my teammates, Valerie, to talk about how the data processing works and how the results looks like.
Yeah, so once you click on submit, in the back end, we calculate based on the attributes you submitted what your COVID risk factor would be. So we take the data set from the CDC and filter for people in the same age group race, and sex as that you submitted, and we calculate the total number of people that have survived and died, and we take the number of deaths and we divide that by the total number of people that have the same attributes as what you entered. And then that calculates your risk factor, and we scale that from 1 to 10. So from this webpage, you can see your results. In addition, we linked more information on the CDC guidelines website so that you can read more. Obviously, we're not using this risk factor to tell you not to adhere to guidelines. It's just to give you an idea of what your risk factor is based on people similar to yourself. And you can also go back and try different attributes if you would like to see people with different ethnicities and ages to see what their risk factors may be.
We want to thank you again for taking a look at our project, and please check it out at our GitHub repository. Thanks for watching. Okay.
Hi guys, so this is Team 8. I am Chinjung, or you can call me Jonathan. My teammate is Sumit. And for our hackathon project, we made a Japanese crossword puzzle. So let's get started. So for the installation of this app, you just need to clone this Git repository from your shell, and you can run this command to install the PySimple GUI. And then after you have completed these 2 steps from your shell, you can then browse to your the cloned Git repository, and then look for this JP crossword puzzle interactive Python file, and then you open it with your interactive Python, and you can run the first shell. And I mean the first cell, and then here you'll see a pop-up window, and this is the Japanese crossword puzzle app. To start a new game, you can click on Generate Puzzle, and then now you can see there are horizontal words and vertical words all labeled respectively, and here are the clues for the Japanese word. So if you want to enter a Japanese character for that word, you can click on the selected tile and then and then click on the correct Japanese character from down here. And if it's incorrect, you'll see that the text will be displayed as red here. And to see the answer, you can click on this button. And then if you want, you can generate a new puzzle. And when you're done, you can click on exit.
Hi everyone, my name is Franklin, and this is a simple Java program that I worked on with two of my colleagues, Betty and Mai. And it's a simple program to help calculate tip when a group goes out together and share a bill. And I'll just go ahead to demonstrate how the program works. It's called the master tip calculator. So first, it asks for the total bill of everyone in the group. In this case, let's say the total bill is $60. And then it asks the tax percentage in the region. Let's say tax percentage is 6%. Next, it asks for the number of people in the group. Let's say this group, there are 4 people. And then it asks for the tip percentage. So what percentage would you like to tip? Let's say we want to tip 5%. The first output is the total bill amount, which in this case for a total bill of $60, if you add the tip and tax, it becomes $67. And then the next output, the program is going to ask whether the bills should be split evenly. In this case, I'm going to choose yes by just typing Y, and it produces how much each person in the group should pay, which in this case should be $17. So that's just simple demonstration of how the program works. I'm going to run the program again just to demonstrate the instance where we don't want the bill to be split evenly. So let me just do that again. Total bill, let's use 60 again. Tax percentage 5. Number of people, let's say 6. Tip percentage, let's say 5. Total bill amount in this case is $66. And I would say no for even splits. So the program is going to ask for the name of each member of the group. Let's say the first person is Franklin. Second person is Betty. Third person is Mai. Fourth person is John. Fifth person is Fred. And the sixth person, since there are 6 in the group, is Yeti. So list the name. Let's say Franklin is gonna pay $10 of the total bill. Betty is gonna pay $24. Mai is gonna pay $12. John is gonna pay $10. Fred is gonna pay $5. And Yeti is gonna pay the last $5. Once I enter the amount for each, the program produces the amounts that each person is going to pay and the tip for each person in the group.